Simplifying radicals video 2. Let's start with the word conjugate. And we should know from the previous video that the word conjugate is simply taking your binomial that consists of a real part and a radical part, a regular number and a radical number, and changing the middle sign. So if I did tell you what is the conjugate of 2 minus the square root of 3, then that would be 2 plus the square root of 3. That's a conjugate. So I hope we all know that from video 1. If we don't, there we go. This is the conjugate of that. Okay? And we also showed that when you multiply a binomial with the radical in it times its conjugate, the radicals end up disappearing and you get a nice beautiful number. Let me show you that one more time. 2 times 2 is 4. 2 times square root of 3 is 2 square root of 3. The negative square root of 3 times 2 is negative 2 square root of 3, and the negative square root of 3 times a positive square root of 3 is a negative, because a negative times a positive is a negative, and the square root of 3 times the square root of 3 is just 3. And we could clearly see that the middle terms cancel out. One's positive, one's negative, and we do see that 4 take away 3 equals 1. So it's crazy. This whole thing up here, 2 minus the square root of 3 times 2 plus the square root of 3, it's actually equal to the number 1. So yeah, it's cool multiplying by the conjugates. When are we going to especially be or have to multiply by the conjugate? When we have a fraction with a radical in the denominator. So let's say we have this fraction 1 over 2 plus the square root of 3, and we want to get rid of the radical in the denominator. Remember, we cannot have a square root in the denominator. So what would we do here? We'd actually have to get rid of that radical. And how do we get rid of a binomial that has a radical in it? You have to multiply by its conjugate, all right? You have to multiply this entire binomial by its conjugate. And the conjugate will be 2 minus the square root of 3. And of course, what you do to the bottom, you have to do to the top, 2 minus the square root of 3. So when we work this out, on top, obviously we'll have 2 minus the square root of 3, because 1 times that is exactly that. But down there is where the interesting thing happens. 2 times 2 is 4. 2 times negative square root of 3 is negative 2 square roots of 3. Positive square root of 3 times positive 2 is positive 2 square roots of 3, and positive square root of 3 times negative square root of 3 is going to be a negative square root of 9, which takes you back to 3. And once again, the middle terms do cancel out. So what do you really have? 4 take away 3, which equals just 1. So we have a 1 down here in the denominator. So your final answer really is equal to 2 minus the square root of 3. So when they ask you to simplify this original fraction, 1 over 2 plus the square root of 3, your final answer simplified will be no more fraction, just 2 minus the square root of 3. So ladies and gentlemen, this is your homework for the weekend. It's this nice, wonderful, beautiful worksheet that I made for you. And if we take a look at the first couple of terms, or the first couple of problems, it's just simplifying. That's not a perfect square number. What are you going to do? You're going to break it down with multiplication to get a perfect square number. So 150 would break down to 25 times 6. There's 6 quarters in $1.50. And if you split the root, you're going to end up with 5 square root of 6. And you can't simplify the square root of 6 anymore. There's your answer. I don't think we need to worry about those simple ones of breaking down with multiplication. We might want to jump to number 5's easy. Let's see. Number 6. 6 is easy, right? Now, could we break down the square root of 10? No. Could we break down the square root of 4? Yeah, right? So what do we get? We end up with the square root of 10 times 2. And could we actually multiply a radical with the number? Yeah, it's like saying x times 2. So what's your answer going to be? 2 square root of 10. You just put it in order and you're done. Okay, let's keep going. I don't know, which one do you guys want to see? 8? Let's take a look at number 8. Dang, 320. That's not fun. Let's actually first simplify, or you know what we should do? we should think about that rule that if you have a square root, you could split the root, but use that rule backwards and see if 320 is actually divisible by 8. Does anybody have a calculator? So it is divisible by 8, 320. So if we put them together and put 320 over 8, and the only reason why I'm actually putting them back together underneath one square root is because you guys just told me that 320 divided by 8 is 40, right? And the square root of 40, that's a lot easier to deal with, a lot easier to simplify than that original problem. The square root of 40 breaks down to 4 times 10. Whoa. And if you split the root, you'll get 2 square root of 10 as your final answer on number 8. Piece of cake. Easy peasy, lemon squeezy. Let's jump to something more fun. Kind of like, let's do 11 and 12 maybe. Start with 11. Now, first of all, 98 divided by 27 doesn't work. So what we need to do is split the root, and we're going to have the square root of 98 over the square root of 27. Okay, now, what is the square root of 98? So, ladies and gentlemen, when we split the root, we actually have two problems. It's like doing the square root of 98. Let me do that on the side. The square root of 98. Now, what does that equal to? I need to break it down with multiplication to get a perfect square number. And I want to go for the highest perfect square number that there is that works for 98, which is 49 times 2. And 49 times 2, if you split it, you're going to get 7 square root of 2. So the square root of 98 could be rewritten as 7 square root of 2. And on the bottom, let's do the square root of 27. I want to do a square root of 27 over here on the side. That breaks down to 9 times 3. And when you split the root, you'll get 3 square root of 3. So on the denominator, you're going to have 3 square root of 3. And you might think that you're done, but you're not. Why? Because you cannot have a square root in the denominator. You cannot have this square root of 3 down there. It's totally fine to have square roots in the numerator, but you cannot have square roots in the denominator. So how do you get rid of a square root in the denominator? You multiply by that same square root value. So I'm going to multiply both top and bottom by the square root of 3. By the square root of 3. So on the top, 7 times the square root of 2 times the square root of 3, that's simply going to be 7 times the square root of 6. You could actually multiply the square root of 2 times the square root of 3 and put them together. You get the square root of 6. Now, down here, the 3 that you see right here, I'm just going to write it as the first part of the denominator. And then I'm actually going to do the square root of 3 times the square root of 3. That is just 3, so I really have times 3. So my final answer for number 11 is going to be 7 square root of 6 over 9. Nothing else to simplify, nothing else to cancel. That is your answer for number 11. Okay, so it's like actually doing several problems in one. You have one problem up here, which was a numerator, the square root of 98. One problem down here, which was a denominator, the square root of 27. And then we also had to worry about getting rid of radicals in the denominator, bless you, by multiplying both top and bottom by that same radical value. So we're going to do one more, or a couple more maybe, I don't know. Let's try number 12 or number 13. Which one, 12 or 13? 13. Okay, so what I would do first is take a look at the denominator, and I would actually simplify the square root of 8. I want to do that on the side. The square root of 8 breaks down to 4 times 2, and when you split it, you'll get 2 square roots of 2. So my real new equation is the square root of 3 over 5 minus 2 square roots of 2. Now, the problem is that you have a radical in the denominator, and you don't want a radical in the denominator. Now, if I didn't have this 5, then I would just multiply by the square root of 2 and multiply by the square root of 2. But the problem is it's a binomial. It's 5 minus the 2 square root of 2. So in order to get rid of the radical within a binomial, you'd have to multiply by its conjugate. There we go. Some of us are awake. So the conjugate's going to be 5 plus 2 square roots of 2. And you're going to do that to the top also, 5 plus 2 square roots of 2. So when we multiply the top, let's actually work that out. That's going to be square root of 3 times 5. That will be 5 square roots of 3. And the square root of 3 times 2 square root of 2, you can multiply the radicals, but the 2 will stay in front. That'll be a plus 2 square root of 6. And that is the numerator of your answer. Now let's take a look at the bottom, the bottom part, the denominator. I need more space, so I'm going to move this up. The bottom part, the denominator, that's where it gets a little interesting. 5 times 5, I want to do it on the side, is 25. 5 times 2 square root of 2, that's positive 10 square roots of 2. And then negative 2 square root of 2 times 5, that's going to be negative 10 square roots of 2. And negative 2 square root of 2 times positive 2 square root of 2 is going to be a negative. The normal numbers, negative 2 and positive 2 gives you a negative 4. And the square root of 2 times square root of 2 gives you another 2. So at the very end, you're going to have a negative 8. So let's simplify this bottom part. And we're going to have 25. These guys cancel out because one's positive, one's negative. And we have minus 8. And 25 minus 8 is 17. So in the denominator, we actually have 17. Ladies and gentlemen, that is our answer. Taking a look at the second column of the homework, it's really, remember, radicals are really like variables, right? So if we take a look at number 18, man, that's the 6th root. I don't even want to think of the 6th root. But the bottom line is, this is kind of like 1 of something, and this is like a negative 4 of that same something. It's kind of like saying x minus 4x. What is x minus 4x? What's x minus 4x, guys? Negative 3x, right? But instead of x, we have the 6th root of 9. And that's your answer there. It's that, you see, it's easy. It's that easy. So all of these, you kind of treat it like if it were a variable. Like on number 19, imagine that it says negative 1/2 x plus 3/2 x. So you're just going to have this as your answer, right? Now number 20, you can't do that because you actually have a square root of 8 and something that's not the square root of 8. So that's messed up. Not only that, it's not even the square root, it's the cube root. And we should know how to do the cube root. Instead of a square root where you say what times itself gives you the number on the inside, it's what times itself 3 times will give you 8. 2, right? 2 times 2 times 2 gives you 8, and that's the 3rd root right there. So what we really have on number 20 is 18 times 2 minus 3 times 3. Why 3? Because 3 times 3 times 3 gives you 27. That's the 3rd root of 27. So we're really going to have 36 minus 9. 36 minus 9. So our final answer is 27. There we go. 27 for number 20. For the final question that we're going to be doing on this video is number 24. We need to take a look at radicals and try to break them down as much as possible. So the square root of 6, I can't do anything with that. But the square root of 81 is what? 9. So I really have 2 square root of 6 minus 9. And then the square root of 24, I could break that down. Not to 12 times 2 because those aren't perfect square numbers, but 4 times 6. That way when I split the root, I will actually get 2 square root of 6. And don't forget about the minus 4 that's out in the front. So I need to bring that minus 4 down and multiply it with the now new number 2 that I have right there. So let me rewrite this whole thing. I'm going to have 2 square root of 6 minus 9 minus 8 square root of 6. And remember, radicals are like variables. It's like combining like terms. You could combine the 2 square root of 6 with the minus 8 square root of 6, and you will get, if you combine this guy with this guy, you'll get negative 6 square root of 6. And what about that minus 9? Just bring it down. By the way, it's always nice to have your regular number in front and then your radical value at the end. And that would be your answer there.